Okay, folks, the surface area of a prism. Mr. Cortez, who cares about the surface area of a prism? I mean, why is that going to matter? Okay, here's the thing. If you make cardboard boxes that ship things to us from, say, Amazon or from J.Crew or from wherever, and you make these boxes, you want to know how much cardboard is it going to take? Because I want to use as little cardboard as possible. One, because it's good for the environment. Two, because it costs me less money. I need to know what the area of the cardboard is going to be for one box. Okay? Now, the surface area of a polyhedron, a prism, or a pyramid, or anything like that, is the sum of the areas of the faces. So I find the area of each face, and I just add it all together. Okay? Now, like I said just a moment ago, we're going to now actually talk about these two figures. Here, let me scoot down so you can see it. Okay, we're going to talk about these two figures, but rather than cutting them up right now, we're just going to talk about their shapes and how much area they take up. Let me ask you something. Looking at number one, what kind of shape does it look like it would make if we cut it out and folded it up? Ian, what do you think? It looks like a cube because it looks like all these little squares are the same size, doesn't it? And if I cut them out and folded it up, I would get a box that looks something like, well, let's see, 1, 2, 3, 4, 5. It would look something like this if I drew it. 1, 2, 3, 4, 5. All right. That's about the right size. Okay, so it's 5 here and 5 here and 5 there. Good. But the question is, how much paper did it take? Well, all we have to do is find the area of each one of these faces. What's the area of this face? This one right here. Paris? That's not its area.
No,
that's the length of one of its sides. Its area is 25. Well, what do you think about this one right here, Elise? 25, right? It's 25 little boxes. 25, 25, 25, 25. For a cube, what's the area or what's the amount of paper that it took to make that little cube? What do you think, CD? How many 25s do we have?
That would be 6.
And 6 times 25 gives us what?
150.
150. You know, whenever I'm working with 25, I like to think of quarters, right? 6 quarters is $1.50. All right. Now, let's look at this next one. What kind of figure does this thing make? And look, let me draw some lines there so we could see where we would bend this thing. All right? Now, that's all the edges where we would bend it. What does this one look like, Sarah? Yeah, but a rectangular what? Pyramid? Prism. We like to call it a box. And this box looks more like a shoebox, don't you think? It looks like this would be the top, maybe, and this would be the bottom, right? And these would be the edges here. This one looks more like a shoebox. Now, to find the area or the amount of paper, we just need to find the area of each one of these little parts and add them all together. Let's do that. What would this one be? It looks like it's 3 by 1, 2, 3, 4, 5, 6, 7. What would the area of that one be, Jack? 21. Beautiful. How about the area of this one? Can anyone see that one off the top? Let's see. Catherine? This one right here.
It's
3 this way, 5 that way? 15. Yes, ma'am. Good. I know it's hard to see from back there. Okay. Harry, what about this one? I know it's 5 this way. Is that right? 5 and 7. 35. Good. 35. What about this one right here, Pace?
15.
15. Eric, what about this one?
Can't see.
Well, it's the same as this one, isn't it?
Oh, yes it is. So 35.
35. And then what about this one stuck out there on the end? What's that one? Elise?
21.
21. When I add them all together, does anyone know what I get? I'm going to pause it so we'll be able to give our answers. But add them all up and tell me what we get. Reagan, do you have it?
142.
Is it 142? I know I've got 70, and I've got 42, and then 30. You got it. 142 units squared. Great job. Next example.